Okay, to get started, the first thing we need to do is we need to import some libraries. And we're going to break our data into two sets, training data and then test data. And what we're going to do is we're going to develop a model, we're going to train it on the training data, and then we're going to run it against our test data. And that's how artificial intelligence works. And so what we're going to do is we're going to import some libraries. And so first we're going to import pandas, and we're going to just type in import pandas as PE. We're going to import NP for NumPy, and that'll give us all the functions that we need as far as pandas and NumPy. And then we're going to do some pre-processing functions and libraries, and those are going to be coming from sklearn. So we're going to bring those in first. Next, what we have to do is we have to import that data, and we're going to bring those in as comma separated values. That's why you're going to see the CSV in that file. And the data is just located out on the internet, and it's located on an Amazon web server. So that's why you're going to see Amazon AWS. So that's for Amazon Web Services. And so we're going to bring those two files in, and you're going to notice the first one is going to be our training data because it's going to say train underscore URL. And then the second set of data is going to be our test data. And that's why it says test underscore URL. All right, so let's see what's first in our data. So let's look at our training data. And let's look at the first few lines. And in order to do this in this program, we're going to type print parentheses train.head. And we're looking for the headings and the heading data. So that's why we're asking the computer to print the train data and its heading. And you're going to go ahead and run that and see what it looks like. All right, so now we know that we have data. We know that we have passengers, survivors, what class they were in, what age they were in, what fare they paid. So now what we need to do is we need to get some information and some statistics on that actual data. So we're going to type in is train.describe. And what that's going to give is that's going to give us some statistics on that training data. And when you hit that enter, or whenever you are able to run train.describe, what you're going to see is that there were over 891 passengers. It's listing right now under the training data as 891 survived. We can see that the average as far as age was 29. That's under mean, under age. And you can also see standard deviation. You can see minimums. You can see what the bottom 25%, what the highest were. So we can see that the highest age was 80, for example. So that gives us 891 records that we can use on our training data. In this next part, we're going to take those statistics and we're going to look at the value counts. And so you're going to see that as an option to provide additional information for us to look at value counts as far as the training data. And so we're going to look at first how many passengers are traveling under each passenger class. So you're going to see the train P class and value counts as an option. And you'll see first, second, and third class. You'll see that there are 216 first class, 184 second class, and 491 third class. And so then we'll also look at the survival rates, and it's going to show us that the training data that 549 people perished and 342 survived. And then if we normalize that, we're going to see the percentages that 62% with, if I round up, perished and 38% survived. We're going to follow that same pattern to look at additional data and analyzing the data as well as looking at the proportions as they relate. And so we'll look at the passengers that survived versus the passengers that passed away, as well as proportions, males that survived versus males that passed away, females that survived versus females that passed away, and as well as looking at normalizing both male survival and female survival. So I've included that information in there for you to look at both the actual data as well as the proportions and what they show. And notice that I'm using the hashtag to give you notes and give myself notes on what the information is, but that the computer does not pay attention to that language at all. Now we know that not all of our data is perfect and that there are missing values where somebody might not have known the age or the cost of a ticket to ride on the Titanic. So with that being said, we're going to use the function fill NA, and what that's going to do is that's going to fill in any of the missing values. And if you notice, we're going to add median at the end, so we're going to use the median so it doesn't skew the statistics on what we find out in the end. So let's see what we have as far as available features in the data. So let's print that trained data. So we're going to type in print parentheses train end parentheses and go ahead and run it, and let's see what we have available to review. Now that you have clean data, we are going to take our training data and actually run our artificially intelligent machine, and we're going to take that clean data and that training data and turn it into arrays. And what arrays do is it allows the computer, and it provides a structure for the computer so it can manipulate it and help make an assumption on what it anticipates will be the outcome. And so we're going to run a function in here that's called fit, and we're going to do it on a decision tree. And that's why you'll see my tree 1 in the function. And the reason why we're creating a decision tree is we're creating this machine to artificially intelligence, to take its artificial intelligence and structure an estimate or a predictor under the class, so the class of the person who was on the Titanic, their sex, so whether or not they're male or female, their age, and also the cost of their fare. And so that algorithm is going to predict and figure out what the relationship is amongst those 4 factors based on the training data that we've provided it, and then give us an outcome. And when we run that function, and when we print the mytree1 score on there, you're going to see that your artificially intelligent system that you just ran completely online has a 97% accuracy rate, because we're taking our training data, which is the data that allows the computer to look at patterns, and running it against the test data. And so you just created an artificially intelligent machine that can predict based on 97% accuracy.